Here now, the first table shows the team with the 4 best records halfway through their season. The second table shows the full season records for the same 4 teams. Which teams has the best record during the second half of the season? Now, here, this example, like here as an example that as I told you, the matrices used for, or is using for present data. So, if I told you like this, here, this matrix is for 3 students, score of the students in math, like one of you get, like as an example, here we have her names is H. I don't know if I talk about names. M and O. The girl, her name is H, get 9, 10, and 7. This is in the first semester. In the second semester, I don't know their marks, but at the final, I know that she get here 20. Here she gets, or not, or we can say 25 as an example. Here she get 30, and here she get 20. And this one, this is the matrix. We normally name it with matrix A. So she get in the first semester, their marks were 9, 10, and 7, and the final their marks were 25, 30, and 20. What about her or their marks in the second semester? How can I find it? I just subtract this matrix which is 9, 10, and 7, and from both sides, like the linear equation. After now, I subtract this matrix from both sides. I will have it like this now. Now like A. Is equal to this matrix. So A is equal to the final score matrix minus the first semester matrix, which is equal to 25 minus 19 is 16, 30 minus 10 is 20, and here 13. So this is the scores for the second semester. Here now we have the sum. The first table shows me the record for the first half of the season, and the second table shows me the records of the whole season, and they ask me now to find the records for the second half of the season, like the first semester, the final, and I want to find the second semester. Here now, this is the table now. Let's represent it in a matrix. This is the first matrix, 30, 11, 29, 12, 25, 16, 24, and 17. Plus the second half, equal the whole, which is 53, 29, 67, 15, 58, 24, 61, and 21. Okay, so now I write the table or I make a matrices from these two tables. I want now to solve them. I will now subtract this matrix, which is 30, 11, 29. Which matrix? Be careful. The matrix which is added to the variable a is to be subtracted. So which it will be this one.
So it's the total minus the first matrix.
Yeah. So minus this one, as you see. So since now there's no space.
Teacher?
Yes.
Teacher, can we make a plus A to the second one?
No, I want to solve it. How can you solve?
Yes.
So let's put this one here now. This is A. This is the first one. Minus the second one. As remembered. The second minus the first. After I subtracting them now from each other, I will get a new matrix. Let's write it here. Now, 53 minus 30 is 23. 29 minus 11, 18. 67 minus 29. 36. Yes, no. No, not 36. 38, I think. 15 minus 12 is 3. 38 minus 25 is 13. 24 minus 16 is 8. 61 minus 24 is 35. And 21 minus 17 is 4. So this is now the paint matrix is for the records for the second half of the season. It's clear?
Yeah.
Yes. Yes, teacher.
Now, which season or which team, sorry, had the best records during the second half? Look here. Look at the first row. The first row is for team 1. The second row is for team 2, team 3, and team 4. Which team has the best records?
Team 2.
Yeah, team 2, the one which has the greatest number of wins will be the best. Let's do now this one here. If B is, this is the matrix of B and the matrix of C, and if you know that A minus B is equal to C, what is the value or what is A? So our equation
It will be C plus B.
A minus B is equal to C. I have B and I have C. I need A. So A, it will be B plus C. Is it right?
Yeah.
Yes.
So matrix B, 1. Well, let's do it like, say, -1, 6, -1, 2, 6, 1, -1, -2, and 4. This is B plus C, which is 2, 0, 0, -1, -3, 6, 2, 3, -1. Let's now add them. Maya, are you here? Maya? Okay, Habiba?
Yes, teacher.
Yes, Habiba. I want you to add now the first row.
So 1 plus 2,
Yeah, which is 3. Okay,
3. 6 plus 0, which is 6.
thank you.
-1,
Plus?
0, which is -1.
The final answer. Okay, thank you. Thank you so much. Other one? Lama?
Right?
Yes, Lama. The second row, please.
No, teacher, it's Maya.
Maya. Okay, sorry. Yes, Maya. The second row. I want you to add the second row.
2 plus
2 plus what?
2 plus -1.
Yeah,
Which is
which is 1. 6 plus -3.
-1.
No, 6 plus -3. Naya?
Teacher, can you? Teacher,
Yes, Maya.
can you hear me?
Yes, yes.
Okay, so 3.
6 minus 3, which is 3. Okay. And
1,
plus,
6.
thank you, which is? Which is 7. Thank you, Maya. Sarah?
-1 plus 2,
Aywa, which is?
1.
1.
-2 plus 3,
Which is 1. Thank
which
you.
is
And
1. And 4 plus -1.
which is a 3. Thank you so much. Thank you. So this is now a matrix A, which is 3, 6, -1, 1, 3, 7, and 1, 1, 3. This is a way how can we solve the matrix equation. Now, you know in numbers, like if you add any number to a 0, you get the same number. And if you add any number to its inverse, you will get 0. This is here how this one here, thus we use the 0 identity. And here we know that if you add any number with its inverse, you get 0. Here we have the same in the matrices. If you add any matrix to the 0 matrix, this one, we called it 0 matrix. That's mean it's a matrix that has a 0 element. You will get the same matrix. And if you add any matrix to its inverse matrix, like look here, 2, -2, 8, -8. That each number has an inverse in the corresponding element, you will get also 0. So let's use now the identity and the opposite matrices. Let's talk about number 1. Here you have two matrices that they are added. Matrix A is 1, 2, 5, and -7. And the matrix, or the second matrix, we call it 0 matrix. That's mean 1 plus 0, 1. 2 plus 0 is 2. 5 plus 0 is 5. And -7 plus 0, -7. The second one here, I add the number to its inverse, like 2 minus 2 is 0. 8 minus -8 is 0. -3 plus 3 is 0. And 0 plus 0 is 0. So the first one, if I told you, I gave you this matrix, which is 2 by 2, and I want you to add it to any matrix and give me the same answer, you will tell me that I will add it to the 0 matrix. How can I write the 0 matrix? Look here. This is the dimension here is 2 by 2. That's mean I have to make the matrix that have the same dimensions with 0 in all corresponding elements. Now, if another way, if I told you now, like if you have this matrix here, and I'm asking you to add it to any matrix to give me a 0 matrix. Now, here you have 3 rows times 2 columns. Here we must have 3 rows times 2 columns. Now then, I note them as a 0, so I must have the same dimension. Now, I want them, as I told you, a 0 matrix, so I must add it to an inverse matrix. Let's add each corresponding number, each number with its corresponding element here, but with an opposite, like 7 and -7. What is the opposite of 4?
-4.
-4. Opposite of 3?
-3.
Opposite of -2?
2.
2. Of -9 is 9, and of 1 is negative. If you add now each corresponding element, you will get the 0 matrix. Is it clear?
Yes.
Yeah.
Okay. Now, as we have a properties for adding, we have adding numbers here also. We have a properties, but for the matrix. The first one, A plus B is an M times M matrix. Okay. Now, if that's mean if you add any two matrices, they told you if A, B, and C are M times N matrices, then if you have A, and if you have B, and if you have C, all of them are matrices with a dimension M times N. A plus B, if I have the answer is M times N, so A plus B, I must get the same dimension. A plus B, which equal to B plus A. We know it, which is the commutative property. If you add any two numbers, any two matrices, you change the order, you get the same answer. And A plus B plus C is A plus B plus C. It's like the associative property. If you keep A here, you put, it is like this. You know what I know. You can make it like this and solve A plus B, then the final answer added to C, or you can add B plus C first, then the final answer added to A. This one we called it the associative property. there's a unique M times N matrix O, which is here, that if you add any zero matrix plus the matrix, you will get the same matrix. And also, if you add any matrix to its opposite, you will get zero. This is the properties of matrix addition.
Teacher,
Yes.
is M times N, you mean about the columns and rows?
Yes,
Mm,
yeah, the
no.
dimension.
Okay.
Now, let's talk about equal matrices. If you have two numbers, you will say that these two numbers are equal. Why? Because you look at them and you compare them. If you have two fractions, you compare both of the fractions by looking at the numerator and the denominator. What about the equal matrices? How can I say that these two matrices are equal? Just compare each element with each other. Like, here we have 3, 7, 2, 5, 1, 9. 3, 7, 2, 5, 1, 9. You will look now at each corresponding element, if they are equal or no. The first one with this one, 2 with 2, 5 with 5, 1 with 1, 9 with 9. Since now all the elements are equal, I can say that these two matrices are equal matrices. So the equal matrices, they must have two things. They must have equal or the same dimensions and equal corresponding elements. So here, to say that these two matrices are equal, you must see if they have the same dimension and equal corresponding element. Like this one here, 0.25 and 1/4, 1.5, 1.5, -3 and -3, 4/5 and 0.8. They are equal matrices. Why? Because each element or each corresponding element are equal, and also they have the same dimension. For this one now here, I can use it like what? Like if I have this matrix here, 3, 7, 2, 9. I told you that this matrix is equal to this one. But here you have A, here you have C, here you have 7, and here you have 2. Can you tell me what is the value of A?
3.
It will be
3.
3. And 7, C, sorry,
It's going to be 9.
9. Since they are equal, so they are each corresponding element here are equal. So this is a way that I can know the values of A or any variable using these properties that they are equal. Let's see now problem number 5 here. In problem number 5, I told you that you have this matrix 9, 3x plus 1, 2y minus 1, and 10. This equal to 9, 16, -5, and 10. They are equal, so 3x plus 1 is equal to 16. So 3x plus 1 is equal to 16. That's 3x is equal to 15. So x is equal to 5. For x equals 5. Then 2 minus 1, 2y minus 1 with -5. Let's say now 2y minus 1 is equal -5, or is -5. So 2y -4, so y is or equals -2. So x is 5 and y is -4, -2, which will be C. Is it clear?
Yes.
Yeah. Yes.
Yeah.
We take the same corresponding element to find the unknown variable. Now here, look at B. Here we have matrix minus another matrix, you get this answer. So that's me. Z minus 10 is equal to 2. So what is above the value of Z?
12.
12. Look at the second one now. 3x minus x is equal to 8. Oh, equals 8, sorry. So 2x equal 8, so x equal 4. And 0 minus 2y plus 6 equals 4y plus 12. So negative 2y minus 6 equals 4y plus 12 minus 4y plus 6 plus 6. You will get negative 6y equal 18. So y is negative 3. So this is a way how we find x, y, and z. Is it clear?
Yes.
Yes.
Okay, now. Refer to the table on the right. Add two matrices to find the total number of people participating in each activity. Subtract the two matrices to find the difference between the numbers of males and females in each activity. And does the order. Okay, look at this one here. Here we have the activities, movies, exercise programs, sport events, and home improvement. They told me about the numbers of male and the numbers of female in each activity. They asked me now to add the total, the two matrices. So let's first represent the first matrix, which is for the male, 59.2, 54.3, 40.5, and 45.4. This is the first matrix, which is for the male. And there's a second matrix here for the female. Now, add the two matrices to find the total number of people participating in each activity. So let's add them now. Since they are 4 times 1, 4 times 1, so using the closure property, it must be 4 times 1. Now, let's add in 59.2 times 56.4. Which is 124.6. 59 plus 54.3, which is 113.3. 31.1 plus 40.5, which is 71.6, and 45.4 plus 41.8 is 87.2. So just adding each two elements. Subtract the two matrices to find the difference between the numbers of males and females in each activity. Let's see now the number of females and males for them. Let's do it here now. Before that, give me 1 minute, please. So let's now subtract them. To get the matrices of the new matrix. To subtract them now, let's subtract each two elements. They told me find the difference between the males and the females. So 59.2 minus 65.4, which is negative 6.2. 54.3 minus 59, which is negative 4.7. 40.5 minus this one, it will be 9.4, sorry. And 45 minus 41, which is 3.6. This is now the difference between the males and the female. C. In part B, does the order of the matrices matter? Is it matter? If you say females minus males or males minus females?
Yes.
It matters.
Yeah, it does.
Yes. Why?
Because it's
Subtraction is
subtraction.
commutative.
Yes, the subtraction is not commutative. Only the addition can, or only adding two matrices. If you change the order, it doesn't matter for you. Okay. Here now, you have to find the value of the variables. Let's see. 4b plus 2 equal 11. And negative 3 equal 2c minus 1. 4d equals 0. Negative 4a equal negative 8. And 2f minus 1 equal to 0. And negative 14 is equals to 3g minus 2. So let's find the variables. From the